All right, let's get right into it. We're all looking for the next big thing in clean energy, right? But what if a huge step forward wasn't some far-off, complicated technology, but was hiding in something as simple as a pencil?
No, I'm serious. Think about that for a second. What if the key to unlocking unlimited, clean fuel was sitting right there on your desk? It sounds a little like science fiction, I know, but some incredible new research suggests it's way closer to reality than you might imagine.
So here's what we're going to cover. First, we'll look at the big problem holding clean fuel back, the bottleneck. Then we'll introduce this wild pencil-powered solution. We'll see how it stacks up in a head-to-head competition, check if it's built to last, and finally explore what this all means for a cheaper, cleaner energy future.
All right, first up, the clean fuel bottleneck. Let's talk about the search for that perfect clean energy source.
You see, for a lot of folks in the energy world, hydrogen is kind of the holy grail. It's a super powerful fuel, but here's the magic part. When you burn it, the only thing that comes out the other end is water. That's it. No CO2, no nasty pollution, just clean, pure H2O.
So how do we get this amazing fuel? Well, the main way to make green hydrogen is through a process called water electrolysis. You probably remember this from high school chemistry. You take water, H2O, run some electricity through it, and it splits the molecule into hydrogen and oxygen. The part we care about is creating that hydrogen fuel, which is called the hydrogen evolution reaction. Now, the idea is simple, but actually doing it efficiently, that's where things get tricky.
See, to make this reaction happen at a useful speed, you need something called a catalyst. And the undisputed champion, the absolute best material for the job, is platinum. It's the gold standard. But here's the massive problem, the bottleneck. Platinum is ridiculously rare and, you guessed it, incredibly expensive. You just can't build a worldwide energy system on a material that costs a fortune. But this is where our story gets really interesting. It's time to introduce an unexpected challenger to the throne, a pencil-powered catalyst.
So, scientists went looking for an alternative, and they found a fantastic contender, manganese carbonate, or MnCO3. Now, what's so great about it? Well, it's made from stuff like manganese, which is one of the most abundant metals on Earth. That means it's super cheap, especially when you compare it to platinum.
And get this, the way they make it is so simple, it's brilliant. It's a process called electrodeposition. You just whip up a solution with some manganese in it, you stick in a graphite electrode, and they literally use the graphite from a mechanical pencil, and then you zap it with just 2 volts of electricity. And that's all it takes. A thin film of this powerful catalyst just grows right onto the pencil lid.
Now take a look at what that film looks like up close. It's not just a flat layer. It's this dense, beautiful forest of tiny little nanoneedles. This structure is absolutely key. Why? Because all those needles create a massive surface area, giving the chemical reaction tons more room to work its magic. And more surface area means more efficiency.
Okay, so we have our new low-cost challenger. Now it's time for the main event, the high-speed showdown. Let's put manganese carbonate up against the reigning champ, platinum. So how do you score this fight? Well, scientists measure something called overpotential. Here's a simple way to think about it. It's the extra jolt of energy you need just to get the reaction going. Kind of like how you have to turn the key a little harder to start a car on a really cold morning. The less extra energy you need, the lower the overpotential, the better your catalyst is.
Okay, check out these numbers, because this is where my mind was blown. At low speeds, just idling along, platinum wins, no contest. It needs way less energy. But watch what happens when we really step on the gas. At high speeds, and then very high speeds, the tables completely turn. Our cheap little manganese catalyst needs way less energy than the super expensive platinum. This is huge. It means for large-scale, rapid hydrogen production, the pencil-powered catalyst is actually better.
Here it is in a bar chart, and it really drives the point home. When you're pushing for the kind of output you'd need for industry, platinum's energy cost just shoots up. Meanwhile, our manganese catalyst is just cruising along, using way less power. That's a massive win for efficiency, right where it matters most.
Okay, so it's fast, but can it last? I mean, a race car is useless if the engine blows after the first lap, right? So that brings us to the next big question. Is this thing built to last? Can it actually handle the pressure?
So the first test was an endurance run. The researchers just turned it on and let it go, nonstop. And it performed beautifully, staying stable and consistent for a full 14 hours straight. That's a really good sign. But what about more realistic conditions? Stopping and starting. So they put it through its paces, 3,000 cycles of turning it on and off again. And the result? The performance barely changed. This proves it's not some fragile lab experiment. This catalyst is tough and seriously reliable.
And you don't just have to take my word for it. Here's the visual proof. On the left, you see that perfect little forest of nanoneedles before the test. And on the right, that's what it looks like after 3,000 punishing cycles. It has held its shape incredibly well. In fact, some of the data suggest it might have actually gotten a little bit more effective over time. So what does this all add up to? Let's zoom out for our final section, unlocking a cheaper future, and talk about why this discovery is such a potential game changer.
Let's just recap the wins here. We're using an abundant, cheap metal instead of a rare, expensive one. The creation method is incredibly simple and low cost. It actually beats platinum when you're making lots of fuel quickly. It's been proven to be tough as nails. And maybe, the biggest thing of all, this discovery throws open the door to finding even more low-cost catalysts just like it. And look, this isn't just me getting excited. The scientists who did this work, publishing in the International Journal of Hydrogen Energy, called it, quote, a promising candidate for large-scale hydrogen production. That's scientists speak for, this is a really big deal. This could be a real pathway to affordable, clean energy for everyone.
Which leaves us with one final, fascinating thought. This whole breakthrough came from combining a common metal with a piece of a pencil. It just makes you wonder, what other simple, everyday materials are sitting around just waiting for us to discover how they could power the world of tomorrow?